and welcome to the August edition of this month's experiment from the Reuben H. Fleet Science Center in San Diego, California. I'm Nicole Schiffer.
And I'm Brandon Elliott.
And this is the coolest experiment ever!
Yes, we're really excited. Today we are going to be playing and experimenting with dry ice. Dry ice. So, I'm going to explain what we're going to use and all the things that we're going to need for today's experiment.
We're going to do a few mini experiments, so
yes, we are.
We're going to go through it as we go along.
Definitely. So we've got a lot of materials. I'm going to go through them. But again, everything...
What is the main thing that we need?
The main thing we need would be the dry ice for the dry ice experiment.
Where do you get dry ice from?
Well, you would get dry ice from the place I'm about to describe as we go through the list of materials, which you can find on our website, www.rhfleet.org, right down there. Okay, so we, first of all, as Nicole so astutely pointed out, are going to need some dry ice. Where can you get dry ice at?
The grocery store.
The grocery store, possibly some drugstores.
Yeah, it's pretty reasonable too. It should be about $5–10 for a reasonable amount if you want to get one for your birthday party or something like that.
Definitely.
Or you can just call us.
Right. Now, dry ice, call her, don't call me. Dry ice is really, 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 really cold.
It's
like,
negative 109 degrees Fahrenheit.
Really cold. So what you're also going to need is a cooler to transport it around. You don't want to be holding the bag. The cooler is off camera, conveniently located over there. But you're not going to be carrying around the bag with your bare hands and stuff like that. So you're going to want to transport it in a cooler, so that's very important. Also, you're going to want to have some gloves like these, thick gloves. Again, I'm not kidding. This is really, really cold stuff.
It will burn you.
Definitely. It does not feel good.
It's so cold it burns.
So cold it burns.
It'll burn off your nerve end. Sorry.
We need some tongs. We also are going to be using a glass jar today. Glass jar is important. Some dish soap. That's going to be one of the coolest things.
That's
we'll
my favorite.
That in a second. A balloon is fun to play with, and also a funnel, which is right here. Okay, and we're also going to want to have some hot water, a cup of hot water, ready on standby. That's going to create the best effect that we. Ooh, look at that.
Whoa.
That we can.
Whoa
All
there.
Right. So let's get started with our first one.
First experiment, just to get familiar with the dry ice, we have our bag here of dry ice. This is what it looks like right here. Once again, 109 degrees Fahrenheit. Just to give you a point of reference, snow, 30 degrees. All right, so this is
30 degrees to the plus.
Way to the plus.
This is minus.
This is way, 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 way colder. And if you do touch it with your actual, come in contact with the skin, it will, burn your nerve endings. You'll get frostbite essentially, and that's not good. We don't want that, especially here in sunny California. I'm good. So what we've done is taken normal tongs that you would use to barbecue or whatnot. We've put it in hot water, and what you're going to do is actually. Did you hear that?
Whoa, that makes
Did you hear
such
that?
a cool sound.
That was great. So what's going on? Why is it making this noise? This is dry ice.
Well, it's just
carbon dioxide.
Yeah.
Like, what?
Yeah. Well, we'll get into that. Wow, that's cool. So this quick change in temperature, you've got the warm water meeting that very, very cold dry ice, and what's happening is it's changing the. It's basically making the metal contract. It's so cold and so much is happening there in the difference between the temperatures that you're actually hearing the metal contract. It's very, very cool. So to speak. Cool. Because of the...
Yeah, it's cool. I get it. Sweet. On to the next experiment. Right?
Yeah. Let's keep going.
Okay, good. All right, so we have, let's see, some hot water again. We're going to put, this is where you need your dish soap. We're going to put dish soap in just a normal jar. This is spaghetti, one of my favorite meals, by the way. You're just going to pour some in. We don't need to be specific here. And you need dry ice. So, oh man, that's a lot. Okay. So we're going to put our dry ice in here. Now we have a special demonstration card for this purpose. At home, you might want to break it up inside the bag. All right, so I have soap, I have dry ice, and I have water. What do you think will happen?
I don't know. I do, but I'm really
What do you
excited.
think will happen?
What do you think will happen?
All right, try it out.
All right, here we go. Ready? All right, so we have the warm water. Again, we've got a big temperature change. There's that. Now this is carbon dioxide, okay? This is a good point to talk about what dry ice actually is. Regular ice, you're all familiar with. Regular ice is frozen water, H2O. This stuff is actually frozen carbon dioxide, okay, CO2. So what's really cool and very, very interesting and unique about dry ice is that it doesn't.
Whoa.
It's very cool. Very cool. It doesn't actually melt into a
Smells
liquid.
really good, too.
It sublimates, what we call sublimate. It doesn't melt into a liquid. It goes directly from a solid into a gas as it changes temperatures. So what you're seeing here, this gas is CO2, and because we've added the soap, what's happening? Do you want to explain what's
The
happening? here?
CO2 is getting trapped in, the CO2 gas is getting trapped in the bubbles that are forming because of the soap and water.
Exactly. So if
Right?
if you could see inside of these bubbles, which we can, and maybe you'll be able to see.
You
here in a
actually, and the
second.
bubbles are safe to touch if you have, if you're doing this at home, you can actually, if you use this nice, long, tall container here, you can actually take the bubbles out. They're not cold or anything like that. They just have carbon dioxide gas in them and smush them.
Yep. That's very cool.
And that's my favorite thing to do with dry ice, by far.
Right. So again, this is carbon dioxide gas. It's not poisonous, but you
Smells
don't
really
really
good,
want to
too.
breathe it in, okay? Because basically, it's just like if you're suffocating. It's just like as if you were suffocating.
But
You-
we don't want to do that.
No, you don't. I mean, we like oxygen. We don't like to breathe in carbon dioxide. This stuff is so cool. Nice.
Great. On to the next
Let's move on to
experiment.
one thing. This will just
I
keep
could do this all
bubbling off
day.
to the side.
All right, so you're going to want to get a balloon,
Keep growing.
and
growing.
I'm going to need your help here.
Okay, dry ice in a balloon.
So we're going to use a balloon and a funnel,
All right.
and you're going to have one person hold the funnel. All right.
All right.
And you're going to want a glove for this.
Am I?
Yeah. So you're putting the balloon on the end of the funnel because we're going to put dry ice in the balloon, and because carbon dioxide solid sublimates and turns into carbon dioxide gas, what do you think is going to happen to the balloon?
I think the balloon is going to get all of that gas and just kind of expand all by itself.
All right, so we don't even need to blow it up, right? So you're going to hold, actually, with your gloved hand.
Oh.
So I'm going to take this little piece. Break it up just a little bit. Once again, if you're at home, you're going to want to do it in the bag, not on the table. All right, so you have a really small piece of dry ice here. Another really small piece. Another really small piece. But I can even feel the cold through the gloves.
Mhm.
These are like,
Yeah.
gloves for liquid nitrogen and dry ice experiments. So that's pretty good. So we're going to get them all in there. All right, and they're all in.
Mhm.
And now I'm going to take the balloon. You want to make sure all the dry ice has gone through before you take this out, and it has. And then you're actually going to seal up your balloon so that it can expand.
Right. It's going to fill up with carbon dioxide, blow up the balloon all by itself.
All right.
It's like a little magic trick.
All right. So we're going to put that to the side. And actually, we have one that we prepared. We started this how many minutes ago? Probably
I'd say just a few minutes ago,
A
actually.
few minutes ago.
Yeah.
Like 2 minutes ago, we put this relatively the same amount of dry ice in here, and it has sublimated into a gas and blown up our balloon. And they can keep going and going because like it's still here.
There's
some
still a
dry
lot
ice
in
in
there.
there. So,
You
oh
can
my gosh,
actually
this
see,
is-
here's ours. It's starting to blow up. So after just a few minutes, you'll have a fully inflated balloon. With this experiment, really, we say it every time, but definitely you're going to want to have a parent or some
Yeah.
responsible adult along
adult
with you.
supervision is a must with this one because it can be a little dangerous.
Yeah, dangerous stuff, but it's a lot of fun. So we hope you enjoyed it and have fun with this.
Great, guys. Thank you so much for watching. Remember, tune into next month's experiment. And also, do try this at home.